Okay, well, it's just after lunch, so I hope I'll be able to keep you awake. My talk is about repurposing old TI calculators. And so I'll explain some of the background, give some indications at host machine selection, talk about some projects. One of them, the RPN 1200, I explained a little bit about 3 years ago at this conference, actually. So I'll talk about some of the improvements since then, and talk about the next step to continue to have fun with that type of project. So background, well, we need more fun and new things to do. So for me personally, it's a hobby, programming, and into very simple hardware projects for the fun of it. We know there are some amazing projects like the 41CL, the Woodstock LP, the WP34S. So what I'm talking about today is nothing like that. It's much, much simpler, much more modest in terms of technical and realization. It's something that's, I think is very accessible. So if that's something that you'd like to pick up, I think it's very, very easy to do. And obviously the repurposing of TI calculators looks like a wide open field. I don't think I've seen anything done so far, so maybe that's the first step. So first I'll talk about the host machine selection. I selected a few criteria which I thought would be relevant, and listed here a few machines, different generations, and explain where they are. So there are some older machines for operations. That's what I've started to work on. The classic second generation would be the SR50, for example, which Gene, I think, explained about it last year or the year before at the conference. And I'll talk about the Majestic product line, how it's called. It's the TI-30, the TI-55, SR40, the business analyst, and so on.
I'm sorry. I missed one word. You said reject. What about the TI-30 and the?
Oh, it's a Majestic product line. It's let's see, here it doesn't show. That's what it's called, Majestic product line.
Majestic. Okay,
Yeah.
I'm sorry.
So, and I looked at the TI-58 or 58C. So, availability, that's important. For example, nowadays, if you want to do a Woodstock LP, you need to find a 25 or a 21 or similar Woodstock model. They're really, really hard to find now on eBay, and they're very expensive. So, are there models which are available, and what's the price? So, the other characteristics I looked at, how many digits, and I'm sorry, there's some missing spots here. How many keys do they have? Are the keys labeled? In other words, if there's a function name on a key, it's a little bit more difficult to repurpose because you have to, one way or another, put a sticker on it. And if the labels of the keys are on a faceplate, it's much easier. You just print a new faceplate. And finally, how easy is it to repurpose? So availability, so as you can see, the older models, the ones which I used for the project I will explain about, they're very available. Prices are relatively low, $16 average. I'll show a box plot later, you'll see what the prices are. And this data I took and I looked on eBay and searched for all these models, how many are they, what are the prices, and calculated the box plots and the average. So it's just a picture at a certain time of the situation. So these smaller, older machines, they have only 8 digits, plus a sign, which I'm not using. 17 or 24 keys, that's a big limitation because there's only so much, so many prefix keys that you can have. The keys are not labeled, so it's easy. I just had to make a new, print out a faceplate. And they're very easy to repurpose. There's a lot of space inside the enclosure. It's very easy to change. SR50, so I found only 4. They were significantly more expensive, $40+. 45 keys, that's nice. They're labeled, that's a little bit of a negative. But the keyboard is hell, basically. I have an example here. So the packaging is nicely made, but so the keyboard is attached here by a metal connector. If you open it, close it, 2 or 3 times to work on the inside, then it breaks, and it's hard to fix. And the keyboard lines, it's not clear how they're made, but it seems the resistivity increases over time, so some keys don't work. If you try to fix that, I spent dozens of hours on one machine. I fixed something else breaks. So I certainly would not recommend to use that generation of classic machines. By the way, I forgot to mention that the TI 1250 is this. It's very simple. The keyboard is separate, you can desolder it. The display is separate, you desolder it, and then you can change the PCB. It's easy to fit in the shell of the machine. So I'll pass some of those around, and you can check out what they look like and estimate that for yourself. The next type of machine, the Majestic Line. So the design inside is very zen. There's almost nothing, the models vary a little bit definitely in availability. By the way, the TI 30 is very, very easy to get. It's affordable. TI 55, not bad. Some of the other models, like the 57, are really harder to find. So TI 30 or TI 55 are good choices. The advantage of the 55 over the 30, and I'm sorry there's an error here, is the number of digits. 12 for the 55, there's only 9 for the TI 30. It's a bit limited. Number of keys, they have 40, all of them, so that's good. Most of them have labeled keys, except the TI 30, so it makes it a good target because it's easier. Overall, as I mentioned, the design is very zen, so, and I'll pass around a couple. So that's relatively easy to repurpose, but there are a couple of things. Number one, the LED display is fixed to the PCB, and I doubt it would be really easy to take it out and put it on something else again. So the best choice would be to actually remove the chip, there's only one, and piggyback a board similar to the Woodstock LP approach, and that board would carry all the signals you need. The next question, however, and we'll discuss a little bit about that, is what are the signals on these pins? And I don't know. So that's a TI 30. And the TI 55 is very similar. It has a wider display, so that's nice. It has a small connector here, power off on. So when I pass it around, be careful not to break that, but it's very, very similar. So similar integration. Yes?
The TI 30 is a very popular TI model number.
Yes.
Do you have any idea how many different variants there are of that?
I don't know. I have only a couple. They did the LCD versions later, and I haven't touched that at all. I only looked at the LED versions. And as far as I know, there's only one plus. You could probably check on datamath.org, the website of Jörg Werner. Lastly, the 58. This one is not bad. There's a lot of space. I mean, the PCB is huge. The keyboard, you can separate it. It seems easy to do. The display, same thing. The shape of the PCB is not easy because it has notches, but you probably don't need the whole space of that. So it might actually be a good starting machine. I haven't started working on this yet, though. So that's kind of the summary. So in conclusion, really, for simple projects like the one I'll talk about, the TI 1200 or 1250 older machines are very easy as an initial one. I think the 55 or 30 would be a good next step because they have more keys, but they offer a different challenge. On prices, these are box plots, so they show the min, max, average, and then first and third quartile of the price. So as you can see, the TI 1200, 1250, there's many of them, and the price is relatively low on average. You can find very, very cheap ones actually, and some people want to sell them for $50, but I don't think they'll be very successful. So the SR50, expensive, and I mentioned hard to repurpose. The TI-30 here, or the Business Analyst actually, it's the same inside really. These are pretty affordable, pretty affordable, relatively available, so that's a good choice. The 58 tends to be more expensive, that would be to make a bigger project. So here we are. So last time, that was in 2015, so I talked about what I had done, the RPN 1200, which is using a TI 1200, and then I designed a PCB for it. At that time, in 2015, I didn't have the PCB, so I wired things one by one, but the PCB is easier, and that brings a little bit of alphanumeric characters for error and stuff like that. It's an RPN machine, scientific, with some unit conversions. So what I'm going to talk about today is the next one. It's the RPN 1250. So I used the TI 1250, which has more keys, 24 instead of 17. I designed a new PCB, so it's PCB Gen 2, let's say. It is a programmable machine, fully alphanumeric, and with some interesting features, I think. So I'll go through briefly an explanation of some of the features and show you how it's made, and we'll wrap up. Key features, it's based on a microchip PIC 18F, so there's different versions. 2680, it's 64K flash and 8 megahertz. Or recently I've used an 18F26K80, which is also 64K flash and 16 megahertz. Plus you can actually multiply the clock speed by 4, so you can actually run it at 64 megahertz, so it's pretty fast. The display is driven by a Maag 7219 display driver. It drives 8 digits. For the 1250 Plus, I added a real-time clock with a battery, so you can get the time and date. The enclosure is the standard 1250, and it uses a 9-volt battery. Program-wise, so it's 98 steps. You can save 3 programs into EEPROM memory, so when you turn it off, they stay and you can recall them. 6 level of subroutines, all the 12 tests, and indirect addressing for memory only. I didn't implement fix-I or GSBI or stuff like that, but recall and store functions and arithmetic or using indirect addressing. 20 memories, actually 30 in total if you address them with the indirect addressing. So I'll go briefly through that. It's just it's kind of a small manual if you wanted to play with it. There's only one prefix key. You press it once, it's F. You press it twice, it's G. You press it a third time, it goes back to no prefix. So then you can access the functions here. So again, programming, you have 20 labels, all 12 tests, subroutines, 6 levels. And run stop is actually only run because to stop you press the enter key actually. I'll need to fix that, but that's the way it is now. You can use store and recall functions, including arithmetic, with the stack registers and also with the indirect addressing register here, which is addressed by pressing enter. So that would be F, stow, and then enter would be I for indirect. Or if you wanted to do recall G, you would be, so the prefix twice to get to G, and then recall, and then you press the run stop button, and it would give you the T register back to the X register. Okay, and for the 1250 plus, I put a real-time clock, so it's addressed with store and recall functions, so you can recall time, recall date, recall day of the week, or store it to initialize the clock. On top of that, for this one, I actually also took the real-time clock is addressed with an I2C or I2C bus. So it's 2 lines, and you have power and ground. And I took these lines also to a connector area so that you can actually wire something outside of the machine and address a peripheral if you want it. This being said, you cannot program the I2C functions yet from the keyboard. And there's an escape mode. It's basically to check the firmware version, to show all the available alphanumeric characters, do a display test. You can make the display brighter or dimmer, and you exit that mode by pressing the Enter key. So internally, what does it look like? So these are the various boards. There were many versions, but for the 1200 and 1250, the chips were different sometimes. Some had discrete components, I suppose, for the older versions, and the newer ones did not. Interestingly enough, sometimes you would have a 1200 with actually a larger 1250 keyboard, but the keys were masked and you could not press on them. So they optimized, maybe made a very, very standard platform and then tailored the machine by just changing the faceplate. So the display has signed. I don't use it because it goes beyond the max 7219 capability. But you select essentially the digit, and then you select the segment here, including the decimal points, and that's how it's addressed, and it's easy to connect it to a display driver. These are all the characters, so obviously W is an issue, plus is an issue, times is an issue, so these are some of the conventions are used. I'm not sure any of that is standardized anywhere, but that's easy to change. It's just a couple of lines of codes in the program to change that. So the keyboards for 1200, it's 5 rows and 4 columns. So you have all the lines on top labeled. For the 1250, there's one more. So and they're not in the same order. So again, I have like a defined area in the program that tells you which keyboard you used. The Max driver, well, it's pretty nice because it uses only 3 lines. You know, PIC doesn't have an infinite number of lines. And I chose the compact 20, Jim, is it 24, 28 pins, I think, the small ones. And so you already need 9 or 10 for the keyboard, so the advantage of that driver is that you need only 3 for the whole display because you multiplex. So you have data in, clock and load pins, and that's how you upload the information to the display. So for the RPN 1250, I used PIC 18F 2550. So basically, the lines there, as you can see, are for the keyboard, and these lines here are for the display. 1250, it's one more line for the keyboard, but otherwise it's the same. And actually, with the same PCB, you can make an RPN 1200 or an RPN 1250. It's the same. Same PCB does both. And you can interchange, you can have a different PIC, all of them would work. For the 1200, if you want to do a 1250 or plus, you need the bigger capacity of the 2680. And for the 1250 plus, so I have the real-time clock, so I need to address that with the I2C bus. And it's, everything is already pre-programmed in the chip, so it's very, very easy to send commands through the RTC bus and get your data. So PCBs, so I used a local company here. I'm not sending that to like a manufacturer in China. I know the guys here, and they were very nice showing me their factory. Actually, they're in Fremont. So That was the first generation here, so I added the holes because that's how the PCB is aligned in the machine actually, so I don't have to cut some pieces inside too much. And the third version is the one that can handle the I2C and the real-time clock. Typically when you order, it's like they send you 6 of them per order, and it's about $50, something like that. So that's what the board looks like. One of the key problems I had is actually here, it's a connector. I designed everything with one connector, and then when I wanted to reorder it, it was not available anymore. So I had to find something that matches, and it's trial and error because it's not that easy in a catalog cell, in a catalog to find out exactly whether a switch is going to work for your project or not. And because we're fitting it into an existing casing, it has to match and stuff like that. But you know, in the end, I think it's worked. So that's what the PCB looks like. The software, and let me pass around. That's a 1250 plus. So it has a real-time clock. There's a battery. Please hold the battery together with the machine because if it dangles, it probably will break here in the connection. And so you can see how it's done inside. Here is the voltage stabilizer to 5 volts. The PIC is down here. Real-time clock is on top here, and the display driver is under, and the rest is just discrete components. So the software, it's not an emulator, so I haven't used Eric's developments for this. I don't know how to use them, but at some point I'd like to be able to do that. That would be fun. So it is not it has some limitations, but also some advantages. Everything is programmed in C using the MPLAB X IDE from Microchip, and I use the free version, so it's not an optimized compiler and so on, but it works very well. There are a few files here, and if any of you is interested, I can share that on the hpmuseum.org or whatever means works. There's a main.c is essentially initializing the machine and runs the event loop. Display.c is low-level display functions, and some of the difficult parts here are managing the decimal point, because it's part of a digit, but you type it later, so you have to go back to the previous digit as you input data to add the decimal point, for example. Or, that was kind of the tricky and difficult part, was managing the inputs, what you display, and then how that is actually stored as a floating point number to be processed. But yeah, that was fun. Keyboard.c, it just scans the keyboard. Memory.c is to load and save from the EEPROM. So as I mentioned, you can save actually either the state of the machine, so all the memories and stack, or the program into an EEPROM non-volatile memory area, and then recall it afterwards. So your three favorite programs can be in there. Runtime.c is program execution, and it runs a flying goose. So it goes forward. Functions.c, that's the biggest chunk. So it manages the input buffer. So after you have input your number, it needs to be processed and converted to a floating point number. It manages all the prefixes and executes all the commands. So it's the biggest part of the software. I2C.c is a short part. It's just the basic I2C, I2C routines, and RTC.c is the real-time clock supports. A couple of comments, and kind of next developments. All the floating points is using IEEE 754 32-bit. So it is quite limited in precision. It's only 6 digits. And some numbers which are really straightforward, like 13 or 0.1, cannot actually be represented exactly in that format. So, so that's probably something to look at. And in the presentation, you'll see there's a small attachment here. It's an Excel file that actually you input a number, and it tells you the whole representation in that IEEE format, and it recalculates the number based on what is in that format. And you can see for 13, for example, it gives you 12.999999 something. So it's not perfect, but that's an area of improvement. My dream would be a full HP29C capability, but there's still quite some way to go to get there. Oh, one more thing I wanted to mention. So the chip that you see on the board for the 1250, so it's just programmed with a simple flash programmer. I have a small breadboard where I put the chip, program it, and then put it in the machine. I don't have inline programming yet. I guess that's the next PCB, but it's very, very easy. So it was a good the development system is very good, so it's very easy to use. Next one. Okay, next step. So, as I mentioned earlier, the TI-30, for example, or the 55 are good candidates, I think, for repurposing. And the attractiveness is that they have more keys, so you can put more functions. So for the TI-30, there's nothing in it. It's completely zen. There's only one chip, and then the keyboard is at the bottom, the display is soldered to the PCB on top, and that's it. So, has 40 keys, that's very good. Now, I was trying to get at the signals on that chip. So, I asked Gene, because I know he presented some stuff on TI machines, whether he knew, but he doesn't have that information. Jörg Werner at datamath.org doesn't have that information. I even contacted TI and they told me we don't have information about that. So it's somewhere, but not easily accessible. So I guess the next step would be to do some type of sniffer or something like that, but I don't have any expertise in that. The only thing I did is try to find out where the signals went and try to guess how that works. And I have two conclusions. Firstly, the L and C are addressing the keyboard, and digits are addressed by these up there, 1, 2, 3, up to 9. So there's some missing lines, and actually there are not enough lines to address all the segments of an 8-segment display. So what I think is happening is that the chip is addressing or selecting a keyboard line and column with the same line that it's addressing a segment on the display. So it's very good to reduce the number of pins, but it's more difficult to understand how it works. So there's some work to be done on that. If any of you knows how that works or has some ideas or how to find out, I would be very interested. And that's I could map the keyboard, which are what lines go to where, so that's available. But that's about it. So there's definitely still a lot of work to do on that. Another question also I have is sometimes when you turn on these machines, they don't boot up properly, and I don't think it's a PIC issue. I think it's the display driver that for whatever reason doesn't start well and it displays 88888, and then you have to turn off and turn on the machine again. I followed their instructions for how to manage the power. It still doesn't work. So my guess is that maybe I buy the chips on eBay, I guess. I'm not sure they're really genuine chips. It says Maxim on it, but they look like they may be out of spec, or I'm completely missing something. So if you want to look at the code and if you have an idea about why it's not working, I'd be very interested as well. I'll pass around a couple of machines, so they're complete. That's a 1200. Oh, one more thing I wanted to mention. So for these, the faceplate is metal. So I printed an adhesive faceplate that I stick to the metal faceplate. And I want to thank Eric for that. He recommended what type of machine to use to cut nicely the adhesive faceplate. It's giving very good results. So that's a 1200. I'll pass it around, and then At the end, it will be on the door prices table. And here is okay. That's a 1250. Same thing. If you press program, you can program some things if you want. And same thing, you put the table at the end. So if you want to take a look at it. So I think that's it. Yeah, I don't have any backup slides. So, do we have any questions? Yes.
So you obviously changed the calculator electronics. Did you have to modify the power supplies at all? They run at 9 volts, right?
No, actually, because for these, what I did, I only kept the display and the keyboard. So I got rid of all the electronics. So I use a 7805 voltage controller. So I bring a 9 volt battery to 5 volts, and that's how I power the display driver and the PIC. Now, for the repurposing a TI-30, you will need to put a piggyback board. The power that comes in is 9 volt from the battery as well, so you would need to do something there as well. It probably would be more complicated. Yeah.
And how many layers is your board? 2 layers?
Just two, yeah. So I opted for a relatively affordable approach. The original PCB is actually much thinner than the one I had made. And you need to cut a couple of notches and stuff like that, which again are additional costs if you order that. So I didn't order that. I cut off the notches myself, and the board doesn't fit exactly the way the original one does. You have to cut off a few plastic pins and stuff that were holding the old PCB but don't work with the new one. So, but it's a 2-layer.
So on that TMCO 983 or whatever it was in the TI, the reason that there don't seem to be enough pins is that the display segment drive is on the same pins that are driving the 8 rows of the keyboard.
All columns, yeah, I think so. So basically it puts the line to 1, and at the same time it selects like one of the segments and maybe one of the columns or one of the lines of the keyboard.
And you can observe this because if the calculator is operating, if you push 2 keys that are in the same column, you'll see the digits get mangled.
Oh, okay, understood. So yeah, so I'll look into that further, see if I can decipher how it works. Yes.
What equivalent calculators are these to?
What equipment on the?
Well, I mean, what machine is your machine equivalent to? Say like an HP 25 or HP. Is it an equivalent?
Oh, the equivalent here is. It's kind of a 29C.
Okay.
It has 98 steps of program, 20 or 30 memories. I think the 29C has 27, something like that. It has indirect addressing, subroutines, so it's a bit similar in capability, but not quite. For example, I don't have ISZ, DSZ functions. There's no GSBI, go to I, Fix, or I. Indirect. So it's a little bit less. The precision of the calculations is not the same at all. That's 6 digits, and again, you cannot, if you do 1, enter, plus till you reach 13, actually, you'll get 12.9999. So it's not there. I mean, it's, the way I see it, it's a hobby project for me. If I'm happy to share it, and it's been very fun to do it. But it's certainly not like any level of 41CL or the Woodstock LP at all, or any previous HP calculator, of course.
So with that 13, that 12.99 going to 13, is that present on the 1200 C2? Or
On the original machine?
Yes.
No, it's not. No,
Okay.
it's they may have used a BCD, binary coded. Digits, but I don't. I just use the standard routines, which are with the NP-LabX IDE. So they're based on that floating point representation. I probably could improve that because actually the reason it says 12.99 is because I don't round the last digit and just truncate. So The next one will probably would be a 9, and if you really round it, that would actually be displayed as 13. But that's maybe part of the next project or improvement. Yeah. Okay, well, thank you very much.